This is the second day we're spending on the last section of chapter 9 on solving a system of equations. Now we need to read a word problem and write and solve a system to represent the situation and interpret the solution. So this first example says Kareem scored a total of 16 points in 2 basketball games, or 2 ball games. In the second game, he scored 3 times as many points as in the first game. So if we let X be the points in the first game and Y let Y represent the points in the second game, we know that my total points has to add up to 16. So the first equation is X plus Y is equal to 16. The second equation, it says in the second game, he scored 3 times as many points as the first game. Well, we know the first game is represented with an X. 3 times as many would mean 3 times X, and that gives you the second game, which is the Y value. So we need to use substitution. So Y is solved all by itself. So Y substitute is 3X. So I'm going to substitute that for Y in the top equation. So then I have X plus 3X equals 16. Solve it for X, combine like terms. 4X is 16, divide each side by 4, so X is 4. So that represents the points in the first game. Now we can substitute this back in for X to find how many points he scored in game 2. So that is Y equals 3 times 4, and Y has to be 12. So as an ordered pair, the solution is 4, 12. And this is the points in game 1, first game. This is the points in game 2. All right, let's look at another type of word problem. I know the sum of 2 numbers is 32, but the difference between the numbers is 8. So remember, sum means addition. So if I call these numbers X and Y, if I add them together, I have to get 32. The difference is subtraction. So if I subtract those 2 numbers, you get positive 8. So on this one, we have to rewrite one of the equations in terms of the other. So I'm going to look at equation number 2, and I'm going to rewrite this for X. So X equals 8. If I want to move this negative Y to the other side, you have to add it to do the opposite. So now I have 8 plus Y is the same thing as X. So I'm going to replace the X in the top equation for 8 plus Y. So I have 8 plus Y plus a Y equals 32. Combine your like terms. This is 8 plus 2Y, which is 32. Subtract 8 from both sides. 2Y is equal to 24. Then divide both sides by 2, and Y is equal to 12. So one of the numbers is 12. Then if you go back up and substitute for Y, you'll find that 8 plus 12 is 20. So the other number is 20. So your ordered pair solution is 12 or 20, 12. This is the X value, this is the Y value. And you could double check. 20 plus 12, that's 32. 20 minus 12, that is 8. So it checks out. And we'll do one more type of word problem. Lola paid $13 for 6 greeting cards. Some of those cards cost $2 a piece and some cost $3 each. So I'm going to use X and Y again. I know that I had a total of 6 greeting cards. So that's X plus Y equals 6. The other equation talks about the money. So I know that some are $2 a piece, so that's 2X. The others are 3 a piece, so that's 3Y. And I spent a total of $13. So I'm going to look at the top one and rewrite this so that X equals 6 minus Y. y. In order to undo the positive y and bring it to the other side, you have to subtract it. So now you have your substitution. 6 minus y is the same as x, so I'm going to replace that down below. 2 times the quantity, 6 minus y plus 3y equals 13. Distribute, 12 minus 2y plus 3y is equal to 13. Your like terms here are negative 2y plus 3y, and that's positive 1. So we got 12 plus y is equal to 13. Subtract 12 from both sides, and you get the y value is 1. So then you can go back to the original, and x is 6 minus y. Well, we found out that y was 1, so x has to be 5. So your ordered pair is 5, 1. And what that means is you bought 5 $2 cards, but you bought 1 $3 card.